There are many considerations in the scale-up procedure for pack tower design. These are diameter, height, wetting, underwetting, loadings, aging, as well as sampling. The first consideration is diameter. It has a direct relationship with HETP, especially for random packings. This is due to either the enhanced distribution or issues with the scale-up procedures. At the column to packing ratio, or DT over DP, greater than 20, lateral mixing efficiently offsets loss of efficiency brought by maldistribution pinch, which has been discussed earlier by Stanley. However, at the range of 30 to 100, where industrial scale columns operate, lateral mixing is far less efficient for offsetting such pinch. The scale-up chart devised by Billet and Makoyak for PAL rings shows that the efficiency is inversely related to the column diameter. In increasing DT over deep, it is quite attractive to utilize bench scale tests using smaller packing size than that used in the prototype. Why? This is because bench scale tests are more effective than large column tests for wire mesh structured packing, in contrast to that of corrugated sheets structured packing. The difference can be accounted from the excessive wall flow. The second consideration is height. It says here that HETP increases with bed depth. This is due to liquid maldistribution. Uneven irrigation results to an uneven concentration profile and localized pinching near the bottom of the beds. This adds uncertainty to scale up. As such, shallow test beds should be avoided. Detection of maldistribution along the bed height can be done using the FRI sampling technique, which will be discussed later. The zone stage, Lockett, Billingham models, and some empirical correlations show that the more stages per bed, the greater is the rise in HETP with bed depth. Also, it must be noted that the end effects become negligible when the bed depth increases. This is especially important in pilot plant columns, for end effects lower the HETP. The third consideration is loadings. Generally, HETP does not depend on vapor and liquid loadings. However, for certain wire mesh and some corrugated sheet structured packings, HETP changes with gas and liquid loads. The load effect may be attributed to liquid rather than the gas loads. As such, pilot tests should cover the range of liquid loads that is expected in the prototype. As discussed earlier, wetting is a phenomenon which should be considered in designing the pack tower. For instance, it could have an adverse effect in scale-up for operations done at low liquid loads. Underwetting is particularly important at the aqueous end of aqueous columns. At the onset of underwetting, HETP becomes strongly dependent on composition, packing material, as well as surface roughness, and the presence of surfactants. For both phenomena, scale-up reliability can be improved in two ways. First, you can employ pilot testing at the composition range expected in the prototype, or you can use identical packing materials and surface treatment in the pilot tests and in the prototype. According to Perry's